Good afternoon, everyone. I am Lieutenant Junior Grade Sydney Wagner, and this is my colleague, Miss Amy Lynn Adams. We're here today to present to you improving Coast Guard decisions in the marine transportation system.
Okay, so pretty much everybody I think would be familiar with the Coast Guard, but the quick high-level overview. Coast Guard is a military sea service. It's a law enforcement agency, maritime first responders, a regulatory agency. The Coast Guard's a lot of things in the ocean domain, known as the guardians of the sea, right? We protect people from the sea and the sea from people. And in the execution of our operational missions, all of them are inherently geospatial. And so the prime example is when a vessel's in distress and they call a Coast Guard watchstander for assistance. The first response from the watchstander is vessel in distress. What is your position?
So how do we fit into this picture here at the Navigation Center? What Ms. Adams just described to you is response to an incident that is already taking place. And we work to prevent such instances from occurring in the first place. And we work to do that through waterways management. In this case, when I'm talking about waterways management, a waterway is essentially a road network in the ocean, which includes ports, approaches, channels, fairways, different routing measures there in the ocean. And we specifically conduct vessel traffic analysis in particular waterways in order to inform management decisions in the Coast Guard. And our division, and essentially using prevention type data and taking a prevention type approach with our data, is new to the Coast Guard. So we are hoping to expand upon the current GIS and analysis capabilities that we have and leverage modern data science models and tools in order to make even better marine transportation system management decisions.
So we use two primary tools in working up our data and providing information to waterways managers. Excuse me. The first tool that we use is Esri's product, GIS, right? And then the other tool we use is IWRAP. It's a program that specializes in quantifying navigational risk.
Right, and just as an example for you here on this screen, what we have is a type of analysis that we were asked to conduct on space module proposed landing sites. So you can see the traffic density that we created there using ArcMap products, and then you can see an IWRAP screenshot as well. And essentially what we were asked to do is figure out what impact there would be on marine traffic if we had to close this certain areas of the ocean for a particular amount of time for there to be a landing. And in order to do these types of analysis, we primarily use automatic identification system data. And this data includes a lot of information about vessel position at particular times. It's historical vessel information. It also includes vessel characteristics such as ship type, length, and draft. So moving more specifically into a couple of our tools here.
So IWRAP does a couple of things really, really well. Why do we use a separate tool? Why don't we do all this in GIS? IWRAP has built-in functionality that really makes our lives a lot easier when it comes to AIS data import and quality checks. It automatically generates traffic statistics, gives you number of trips per ship, provides heat maps, density distributions, but most importantly, it builds a marine traffic model. This traffic model is then used to determine the risk of collisions, elisions, and groundings in a specific waterway. And really the value in this is being able to see the changes in a risk profile for a waterway between the initial state and say a future state, such as adding an offshore renewable energy installation like a wind farm. There's also additional functionality that we haven't even begun to look at yet, such as a module for emissions modeling. So IWRAP does a lot of great things for us. It's super fast, and it gives us great answers and tools and things that we didn't have previously in the Coast Guard. However, there are a couple of things that we started, as we started to get more familiar with its capabilities and the capabilities, or the possible capabilities of GIS, started thinking, man, maybe we should talk to some folks who have a little bit more experience in this. So one of the things that we found is that the risk probability that is calculated in IWRAP is subject to a 1-year time frame. There is no sub-year sensitivity. So if you have 3 months of data, it's multiplied by 4, and boom, you have your data set. The risk is not calibrated or tied to a standard. So if you have a result which indicates that you would have perhaps 1 grounding per every 160 years, that is not necessarily a meaningful number. Once again, the value is in the difference in the change in risk in a given waterway. Small sample sizes yield lower confidence intervals in your results. And for instance, a Baltic Sea study that had correlations on collisions of 20 to 25%, but then again, the number of ship transits was below 1,000. By example, Straits of Malacca, much higher trafficked body of water, and the correlations were much stronger. Ship traffic projections into the future are based off of essentially expert opinion, rules of thumb, talking to ports and pilots associations. But the big thing that we started to notice is that all the available tools right now, IWRAP is one of many, use a model framework where risk is derived through fault tree and event tree modeling of discrete navigation processes. There are causation probabilities that are either empirically derived or derived using Bayesian networks. And our direction, we want to explore whether there is a new framework or a better framework to employ in the pursuit of quantifying risk, which is what brings us here.
So talking about these future methods and some of the research that we've done looking into these areas, when I started researching these problems, I found that traffic prediction has been of interest for many years, mostly related to vehicle traffic, but over the past 10 years or so, more and more attempts have been made to actually predict marine traffic. And that relates to, the AIS data that I talked about earlier. There's an increased quantity of that data, and the quality of that data has gone up significantly over the past 10 years or so. So there's 2 general approaches that people take when they're looking at predicting marine traffic. And the first is, where will a vessel be on a route given where it was previously on the route? And what will the overall traffic volume be in a port or in a waterway in the future, given what we know about the past traffic volume in those particular areas? So some of the types of models that I saw included time series forecasting, clustering analysis, but what especially caught our attention and was of particular interest to us are some more recent models that use spatial temporal type prediction. When you think about the data sets that we work with and the information that we have a complex network of ports. We have, anchorages, places that people dock up, all different locations along the coastline, in addition to the AIS data, which is very time-based. Where was a particular ship at a certain time, and why was it there, and how does that play into the overall traffic picture? So we're hoping to pursue some of these models further. And another thing I wanted to mention is that something I saw in common with a lot of these studies is that they say, this analysis is useful for port managers and waterways managers, and where are those people? And no one is really taking these analyses and actually applying them to the decisions that are being made in these waterways and in these ports. And so we strive to bring that capability to the table. We're hoping to come up with a flexible, reusable type model or framework to predict marine traffic in a port or in a waterway, as well as associated risks of events such as collisions, elisions, groundings in that waterway. And we really see GIS and the capability that Esri Tools has as a potential tool that we can use to come up with these models. And with that, we look forward to your questions at the end of this session, but our contact information is also posted here because we would love to further discuss these topics with you if you are interested. So thank you very much.
Yes, thank you.